This is the readout for our first chapter in our first week of class, which is dealing with fractions. Fractions can be used to represent a part of a whole. For example, the diagram of the circle. This circle has two equal parts. It is divided into halves. One part is called 1/2. So dividing something into two equal parts is dividing it into halves. For practice, I'd like you to try the shapes below following the same pattern. Let's do one together verbally. This rectangle has how many equal parts? 1, 2, 3, 4, 5, 6 equal parts. It is divided into sixths. One part is called 1/6. So the number of equal parts it's divided into that many, although the wording changes. So 2 equal parts is halves, 3 is thirds, 4 is quarters or fourths, 5 is fifths, 6 is sixths, 7 sevenths, and so on. Try the remaining practice questions on a separate piece of paper. Next, expressing fractions. We can express a fraction by talking about the number of parts and the total number of equal parts. For example, a pizza. We have a diagram of a pizza. There are 3 pieces remaining out of a total of how many possible pieces? 4. So the number of pieces that there are, that number goes into the top of our fraction, and that top number is called the numerator. In this case, the numerator is 3. How many parts do you have? 3. The bottom number is called the denominator. That's how many parts the whole is divided into, which in this case is 4. If we had a whole pizza cut in this fashion, there would be 4 pieces. So this pizza has 3 out of a possible 4 pieces, or the amount of pizza remaining is 3/4. Practice. Show 4 different ways to color half of each square. Circle the shapes that are divided into thirds, and put an X over the shapes that are not. Remember, if divided into thirds, that means it has to be divided into 3 equal sized parts. So if it's divided into thirds, the 3 parts it's divided up into have to be equal size. So be careful. Next, simplifying fractions. Fractions can be reduced by dividing the numerator and denominator by the same number. A fraction is in simplest form when it cannot be reduced any further by division. For example, if you were given the fraction 2/4 or 2/4, you could simplify it. And by simplify, we mean you could divide it by the same number to make the overall fraction look as in smaller numbers. Now 2 and 4 both can be divided by 2. If we divide the top, the numerator, by 2, that gives us 1. If we divide the bottom, the numerator, by 2, the denominator rather, that gives us 2. So the fraction 2/4 is the same as 1/2, but 1/2 is in simplest form. The same with the next fraction, 5/10. We can simplify by dividing both the top and the bottom, the numerator and the denominator, by 5. 5 divided by 5 is 1, and 10 divided by 5 is 2. So 5/10 is equal to 1/2. Same thing for 3/9. We can divide both 3 and 9 by the number 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So 3 over 9 is equal to 1 over 3. And a big final example, 75 over 100. What is a number that goes into or can be divided out of both 75 and 100? 25 is such a number. What happens when we divide 75 and 100 each by 25? 75 divided by 25 is 3, and 100 divided by 25 is 4. So 75 over 100 reduces or simplifies all the way down to 3 over 4. They are equal to each other. Try writing the following in simplest form for practice. Our final section, equivalent fractions. Two fractions are equivalent if they have the same simplified form. They represent the same portion of the whole. For example, on this semicircle, it's divided into 3 parts, 1, 2, 3, and 2 of them are shaded. So the shaded fraction is 2/3, or 2 over 3. In the second one, in red, this semicircle is divided into 6 pieces, 1, 2, 3, 4, 5, 6, and 4 of those are shaded in. So the shaded in portion of this shape is 4 over 6. However, if you take a step back, we see that both shapes overall are filled in the same amount. And in fact, 2/3 is the same amount as 4/6. They're in different forms. This one is simplified, this one is not simplified, but they have the same overall value. The same can be said for my 3 rectangles. 1/2 is the same amount as 2/4, which is also the same amount as 4/8. All of these are equivalent fractions. Practice using equivalent fractions by circling fractions that are equivalent, and then checking to see whether statements are true or false, and finally writing an equivalent fraction given another fraction. So please try these practice examples. If you run into help or run into problems, let me know and I will be available to help. That's today's lesson on fractions.